by 5, which is 14. So these are the expected counts. Now we saw some problems where it would like tell you like, oh, we think like, 30% do beverage and 10% nap and 5% walk and 15 and so on. Like it's not always the same number. Sometimes you have to multiply by
Yeah.
a value. Um, okay. Um, so give me just a moment here. All right, I'm back here. So the I'm looking at part B. So let's just calculate the chi-squared. So to do that, you would take summation of the observed minus the expected squared divided by the expected. So it looks maybe more complicated than it actually is. It's 20 minus 14 squared over 14 plus 16 minus 14 squared over 14 plus 10 minus 14 squared over 14 plus 9 minus 14 squared over 14 plus 15 minus 14 squared over 14. All right, so do you want to try calculating that? One thing you could do to make it easier is to go into practice. You'd be like, okay, well, that's really 6 squared. That's really 2 squared. That's really negative 4 squared, but it's really positive 4. Negative 5 is really positive 5 because you're going to square it. That would be sort of a shortcut here to doing that by hand. But do you have a calculator available to you?
Oh crud! I forgot it in my room.
All right. Definitely would be helpful to use today. So leave that up to you if you want to grab it.
I'll go grab it real quick. Okay. So I will calculate this.
Yeah, so just to be clear here, like the shortcut here is it's 6 squared over 14, 2 squared over 14,
Okay.
4 squared over 14, 5 squared over 14 plus 1 squared over 14.
Okay. 14 plus 4 squared over 14 plus 5 divided by 14 plus 1. Yeah.
Okay, great. So the next thing is to calculate the p-value of this. And that's a little bit challenging here, depending on how we do it, but we need the degrees of freedom. The degrees of freedom is like the number of rows or the number of columns minus 1. So this probably have 1, 2, 3, 4, 5 columns are the categories, you can think of them.
Oh, yeah.
So there's 5 categories. So it's 5 minus 1, which equals 4. And then the sketch here, the chi-square distribution always kind of looks like this.
Yeah.
And you just put your test statistic value 5.74 here, and you're finding the area in the tail. Now, how are you going to do that on the test? Is there a table?
Yeah,
Do you guys?
there is a table that he'll provide for us.
Okay. So I'm gonna use some software to get it.
Yeah, we use a table.
7.4, comma 4. All right, almost there. All right, so the answer here is that the p-value is 0.2194. You're really generally, I mean, the alpha values you're going to see on this test, probably the most common was 0.05. You might see 0.01 and you might see 0.1. This is bigger than all of them. And that's kind of what you need to focus in. It's like, okay, it's a lot bigger. So I can now answer the following questions, which is
Okay.
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 I'm gonna reject or fail to reject in this case. So since the p-value is greater than alpha, you've not rejected, fail to reject. And then the not rejected always goes with the not evidence.
Oh, okay.
If it was rejected, which it's not, but I'll do that in a different color here. If it was rejected, that would go with the there is evidence.
Okay, I see.
There's kind of a pattern to that. All right, number 3, go to number 3 here. Is this the same teacher as yours?
Yes.
Oh, good. So possibly you'll get a very similar. Does this look like his or her style?
Yes.
Okay, that's good. If you can find more of these, I would recommend looking for them and working through them as much as you can.
Okay.
Okay, so researcher investigated the relationship between length X and weight Y of snake. He observed a linear trend and obtained the least squares regression line. Length was measured in centimeters, weight in grams. Longest snake in the sample was 1.8 meters. Sum of squares, total sum of squares are okay. Interpret the slope of this regression line in the context of the problem. Be very specific. Okay. So they're looking for a very specific language. They're kind of a recipe here. A 1 unit increase in X. Now, instead of saying that, you have to say, for every one, was it in centimeters? Yeah, for every 1 centimeter increase in length. So the first one's like this generic start, but you have to be specific to your problem. For every 1 centimeter increase in length, comma, there is and this is the slope, and it could be increase or decrease in Y. So for every 1 centimeter increase in length, there is a 6.89 gram increase in weight of the snake. You might even throw that in there, like of the snake. And that's why the instructor's saying, like, be specific. Don't just give me the slope. Tell me what it means in terms of
Oh,
length.
I see. I remember this
So
from.
you have to give him enough words that convince him or her that, hey, I understand what the slope is.
Okay.
And
Yeah, I get it.
all right. All right. Part B here is coefficient of termination. That's what's called R squared. And it has a formula related to these numbers here. Okay, so if you remember, there's this other formula that says sum of squares regression plus sum of squares error equals sum of squares total.
Oh,
In your problem, you're given that this is 9811 and this is 1194. Could you calculate SSR for me, please?
yes. Okay. Got 8,617.
And so the coefficient of determination is SSR over SST. So these might be some things to include in your reference sheet.
Okay. Chapter 4. SSR. Okay.
So you have SSR. Your SSR is 8617 over SST, which is 9811. You're just going to divide those values.
Okay.
And it is a decimal. So you might go out to like, it says there are 4 decimal places.
Divided by 4. So rounding that up, I got 0.8783.
Good.
Okay.
So that actually leads us to the third one. You take that number.
And then move it to decimal places.
Yeah, exactly.
Okay.
All right, now to find R is the square root of R squared, but it's plus or minus. So you have to take the square root of that 0.8783 number.
Okay.
Now to determine whether it's positive or negative, let me know when you get caught up. Well, that's an important discussion.
Okay.
So the correlation coefficient has the same sign, and that's probably important to make a note of. That has the same sign as the slope. So if you go back and look, the slope was positive.
Yeah.
Since the slope was positive, that means that this is positive.
as the slope. Okay.
We're on to part C now, which is it says use the given equation to predict the weight of a snake that is 1.5 meters. Your instructions being slightly deceptive here. X is supposed to be in centimeters. So you have to be able to convert 1.5 meters to centimeters. So you do that by multiplying by 100. I don't know how you would know that. So you might ask, you might just say, hey, look, this is in the science class, how many centimeters in a meter? That is the number that goes in, because you would end up getting a negative weight, which wouldn't make any sense.
Mm-hmm.
And when you get that, like, just go ask, just say, hey, I don't think this is right. Sometimes they'll tell you, sometimes they'll give you a nod or something, tell you. So grab your calculator and go
Okay.
ahead and calculate that, please.
Okay. Okay. Got 730.43, if that's correct.
Okay. That's in grams. I mean, that's
Yeah.
probably reasonable. All right. The next question here says to explain briefly why predicting the weight of a snake that is 2.2 meters long may be unreasonable. Oh, I'm sorry. They actually did give you the conversion here. I didn't even notice that. That's good. And they give you the conversion here as well. So you don't have to actually do that. So why is that unreasonable? Well, the teacher tells you here, if you look back up in the original question, the longest snake in the sample was 1.8 meters. There's this thing called there's interpolation, and then there's extrapolation. So extrapolation is when you're outside your original data set. And interpolation is when you're inside or within, you could say, maybe that's a better word, within the data set. So your teacher's looking for an answer here that says something like, while you could calculate it, you wouldn't necessarily be comfortable with the answers because the input is outside of all the inputs that you used. So like if we were to, graphically look at this thing, like you have a bunch of data points here and you're trying to estimate something over here. And all we really know is that it's linear in here. Do you feel like you could write a sentence or two on that if you had to?
Um, I would say it's linear, but with some outliers. But
That those words are not, they're not looking for those words. They're looking for interpolation and extrapolation. So linear interpolation is like if you choose an X value in here within the like bounds of your data set, that's interpolation. As soon as you go outside of it, it's extrapolation. And that's where you don't know what's going to happen. You're unsure if your results will work.
Trying to think.
In this problem, 1.8 is there and 2.2 is here. So it's outside of they're looking, the teacher wants to see one of these words and then outside.
Trying to think.
Like you don't have to for me. I'm just asking, do you feel like you have enough here to be able to write
I
something?
think I may need some when I'm defining something in words. It's just I think I need to like do a bit of trial and error on it.
Do you want to try typing something in the chat and I can edit
Yeah.
it or revise it?
Yes. Okay. Where's the here it is. Oh my god. Okay. Okay. Hi. Ah. I don't.
Yeah, let's take a look here.
Okay.
Okay, that is a good answer. I like it. Do not overdo it. Like less is more most of the time. I know that doesn't feel right as a student, but you just don't want to grade like a bunch. They don't want to read a long thing. They just want to see the right words. Okay, let's talk a little bit about proportions. Take a look at one of these multiple choice questions. Okay. So it says here, suppose you have the following alternative hypothesis, p greater than 0.8, and your test statistic is z equals 1.57. Compute the p-value for your test. So here is 1.57. Do we want the area to the right or to the left of this?
To the right.
To the right. Okay, so how are you going to do that?
Um, Alternative.
How are you going to find the p-value on your test? I guess what I'm asking. Like, do you have your table? Do you have something you can
Table.
use?
Yeah, I'll just use the table.
Okay, just for one here, make sure you can do this one.
Okay. Sorry.
Okay.
No, that's not one. Okay. Hold on. According to the table, it would be B.
That's the area to the left. That's why I wanted to make sure we.
Oh, now I remember. You have to subtract it by 1.
Right. Yes.
So
Like it wasn't wrong, but that is the kind of thing you'll see on the test there.
they'll provide a table for us. So
Okay. All right. Very good. Let's move on to the next question here.
make a
This
note.
is another actual area problem, so we might as well have you try this one here. So it says, suppose the p-value for your right-tailed test was 0.037. So they're saying here was the test statistic. This is 0.037, but the alternative hypothesis is a not equal to. How many tails is a not equal to?
It's two-tailed.
It's two-tailed. So do you remember what you have to do to this p-value here?
Don't you have to, I believe, was it added or not?
You
Did
double it.
you
You
double
double it.
it?
Yeah.
Yeah.
So you wanna make some sort of a note that when this is right, this is left, this is two-tailed, and you might make a note that you double it.
Tailed. Subtract by 1. Two-tailed. Double it. Okay.
Right. Any questions on that?
No, it's pretty straightforward.
Right. So really quickly, this is if the confidence interval, if it contains the p estimate, you do not reject.
Ah,
If the confidence interval does not contain the p estimate, and this is true for anything like x bar or any of the other stuff, you do reject. Maybe we'll just say reject. So keep that in mind as you try to answer this question here.
okay. Suppose you did not reject. Oh my God. Um. mm, Contains yes. Mm, maybe computed. Oh God. Okay. Maybe I'm overthinking it. I don't know.
Yeah, but it's not C.
I
That's for
don't
sure. Okay, so here is the information you need. You need that and that, I guess. But I mean, that's the key thing in there. Which one of these two options is for did not reject?
the first option.
Okay, so does the confidence interval contain the p estimate?
No.
Well, so what I wrote is that the confidence interval contains the p estimate.
Yeah.
That means,
Yeah. Yeah. So
okay.
my bad.
And if it said, suppose you did reject, well, then it does not contain the P estimate. Okay, let's look at a few more here. Um, all right, so there is you typically get a question in the chi-square test about what is the null and the alternative hypothesis. Keep in mind, equal and not equal. You can think of it as not equal, equal. The not is always going to go with the word not.
No.
I mean,
Yeah.
even though you don't know what the right one is. So this one is correct. All right.
Okay.
Okay. So let's go back and look at the words and see how would this be organized in a table. So it says a bookstore owner wishes to determine if there's a relationship between gender and type of book selected by his customer. He collected a random sample of customers, them according to gender, male and female, the type of book they selected: mystery, romance, self-help, other. How could we organize this in a table? What would that look like?
Between gender, type of book selected by his customer.
Like, how could you organize male, female, mystery, romance, self-help, and other into a table?
Wouldn't you use like that kind of table that
Yeah, I mean, I'm trying to just not give you the answer. I'm trying to get you to try to tell me how many rows or columns would you need? Rows go
oh
this
oh
way.
okay.
How
I
many
just
columns?
need to draw it. I just need to draw it.
Yes. Yeah, exactly. So I know sometimes it's unclear because if I start drawing it, then you already have the answer. No good there.
No, it isn't. So you would have male and female. Um, hold on. And then you would have four. Oh, crud. I messed up. And then you would have the totals. So
Okay, so there's kind of two ways that I see this. You can
I
either put male and female, and then you can go mystery, romance, self-help, and other. Or alternatively, you could go male and female. Oh, thanks for trying to go. Yeah, that's good. No, you don't have to show anymore. That's okay. I just wanted you to work something out. Like it's
that's what
uh
I
okay. So depending on how you do it, this is what either way is fine. The degrees of freedom here is the rows minus one
okay.
times the columns minus one. So this is another formula that you'll need. So depending on how you do it, it's either 4 minus 1 times 2 minus 1, or 2 minus 1 times 4 minus 1. Uh, you end up getting 3.
Okay.
All right. So the reason that's important is there's a question now where they ask you to find the rejection region of your chi-squared test. And it's based on two things. It's based on the alpha and the degrees of freedom. So your degrees of freedom is 3, alpha is 0.05. So you're looking for 0.05 in the tail here, and you have to look up the value here. So it's easy to choose the wrong value, I guess, is the point. And you said you'll have a table.
Yes.
All right. Where's this is even if you don't do it with me today, you definitely want to like get familiar with how to do that.
Right.
So it ends up being 7.815, that one there.
Okay.
All right. Do you typically get extra credit questions?
Yeah.
Okay. All right. The p-value for the hypothesis test can be negative. No, it always greater than or equal to 0, but really it's between 0 and 1. So this is false, but that's maybe something to put on your note card, is that the p-value, it's between 0 and 1.
Okay.
It's, yeah, we'll just leave it at that.
Okay.
All right, next thing here, linear correlation coefficient is 0.79 is stronger than minus 0.79. These are actually the same. So another false one. So the way this typically is they'll ask you like a multiple choice. They'll say which is the strongest correlation, and it'll be like 0.21 minus 0.55, 0.97 minus 0.98.
Okay.
And so the strongest one, this one's actually the strongest. It's the biggest number without the sign.
Okay.
Have you looked back at your old test to know if your teacher tends to emphasize like more false answers on these? Because I'm seeing a trend here.
Yeah, I'll definitely look into it.
Okay. All right, so it says here in linear regression analysis, it is appropriate to fit the least squares regression line to the data, even if the plot of our data clearly does not show a linear trend. So what the instructor's saying here is, let's say your data looks like this. He's saying, well, should you still do this? And the answer is no, you should not. So if it doesn't look linear, you don't do the regression analysis.
Okay. I see.
Okay. Number 4 here. It's written weirdly. It is true. So the p-value is equal to the alpha in this, this scenario they're given. Okay, last one here. It says degrees of freedom for a chi-square test depends on the size of the samples. Um, that is false. It depends on the number of group. Either like we did a couple of table problems today,
Yeah.
or like that. It depends on that. Now, you're supposed to have at least 5, I believe. So that might be another little thing. You might look at your notes and look for like little things emphasized like that. These could be pretty tough. All right, we're gonna